So this is going to be a video that's a little bit of extra practice with 5.3 and 5.4, setting up and solving proportions. This first section, it all goes with this packet or these worksheets that you got in class, so make sure you have this with you. These are your video notes. This first part is comparing part to part versus part to a total or part out of a whole ratios. So let me give you a couple examples together. It says Jeremy got 16 correct answers on a test with 20 questions. I need to think about if that's comparing two parts. So these numbers that they give me, are those two different parts, or is that one part and then out of a total? Well, this is how many he got correct, and this would be the total number of questions. So what they're giving me is actually a part to total comparison. He got 16 out of 20. Or I could simplify that, and it would be, what, 4/5? And I could divide that, and I would get 0.8, or he got 80% of the questions correct. Okay? But they also asked me for a part-to-part comparison, so I have to think about what the two parts are. Well, if he got 16 correct, what's the other part or the other group? Well, how many did he get incorrect? 16 out of 20 right means he must have gotten 4 wrong. So now if they want a part-to-part ratio, I could say the ratio of correct answers to incorrect answers is 16 to 4, or that would simplify down to 4 to 1. So this is a part-to-part comparison, comparing how many he got right to how many he got wrong. So in each of these questions, they're going to ask you for both the part-to-part and a part-to-total ratio or comparison. And then you're going to have to think about all the information they give you and how do I write both of those out. So let's try one more. During the last several weeks, we've had 35 sunny days and 20 cloudy days. So assuming that the days are either sunny or cloudy, I have two groups here, sunny and cloudy. Those are my two parts or my two groups. So if I wanted to write a comparison or a ratio, just comparing those two numbers, I could say 35 to 20, right? Sunny days to cloudy. I can write it like that, or I could write it up and down like a fraction. Let's say I don't have a lot of room. 35 to 20, like that. And then I should simplify it. If I simplify those numbers down, I would get the ratio, let's see, I could divide by 5. So I'd get the ratio 7 to 4. The ratio of sunny days to cloudy days is 7 to 4. Okay, what about if they ask for a part out of a total? Well, I know there were 35 sunny days and 20 cloudy days, but how many days does that make total? So I actually have to add those together, and I see that there were 55 days that they looked at in total. So this is sunny, let's do sunny days. There were 35 sunny days out of 55 days. Let's simplify that. So again, divide by 5 maybe, and I get this. And then if I wanted to find the percent, 7 out of 11 is 63.6%. So 63.6% of the days were sunny. So I'll talk through one more and then you can try a few as practice. So Bozo's lacrosse team played 40 games and won 25 of them. Well, if we know we played 40, that's got to be a total, and he won 25, that's one of the parts. So if I want a part to total comparison, that's going to be easy. How many wins did he have? He had 25 out of 40 games were wins. Simplify that. So divide by 5 probably again. And then actually divide that on your calculator or do the long division. They won 62.5% of their games. Because they gave me the part, they gave me the total. But what if they want part to part? Well, if they won 25 of the games, then they must have lost how many? Well, 40 minus 25, 15. They must have lost 15 games. So now my part-to-part comparison could be wins to losses. And they won 25, they lost 15. That would simplify to, what, 5 to 3. So the ratio or comparison of the two parts is wins to losses is 5 to 3. So right now you go ahead and try 4, 5, and 6. As practice, read it carefully, figure out if they're giving you the two parts or one of the parts and then the total, and then come up with the part-to-part comparison and the part out of the total, and then make sure you simplify them all, simplify everything, and divide these to get percents. And then we'll come back and check, so pause now. Okay, there's the answers to 4, 5, and 6. So we are comparing yellow shirts to orange shirts, and then how many yellow out of the total. And the next one, how many hits to misses, and then how many hits out of the total. And then in number 6, how many right-handed to left-handed people. Simplify all of these ratios down. And then how many right-handed students out of the total. So take a second to check that, and then we'll move on to the next section. Okay, sometimes you'll see problems where you need to use a unit rate to then set up a proportion and solve a problem. So here's some examples where I start with a unit rate. I know it's a unit rate if I see per in there as part of my rate. So like 23 miles per gallon, MPG, per, that's telling me it's giving me a rate. Or right here, 45 words per minute when you're typing. That's giving you a unit rate. How many words can you type in 1 minute? So to set these up, I'm giving you a hint. It says split the unit rate up into its 2 parts, into its 2 numbers. Then you'll have enough to set up a proportion. So here's what I mean. A car gets 23 miles per gallon. How far will it go on a 15-gallon tank of gas? Well, 23 miles per gallon, I have to split that up into its 2 parts. That actually means 23 miles for 1 gallon, right? Or 45 words per minute. That actually means 45 words typed in 1 minute. Remember, unit rates always have a denominator of 1 in the bottom. So I got to split it up. Then I can go back to my question, keep reading, and see what else they give me. So number 1, how far can it go on 15 gallons? Well, I'm going to finish my proportion by lining up the labels. So 15 gallons would go on the bottom, and how many miles can it go would go on top. Then I'm just going to cross multiply 1 times x and 23 times 15. So 345, and in this case I've already got x by itself, 345 miles. How about number 5? 45 words in 1 minute. How many words, so this is what I'm looking for, could he type in a quarter of an hour? Well, I gotta think. Quarter of an hour is how many minutes? Quarter of an hour would be 15 minutes. And cross multiply, right? So 1 times x, 45 times 15, 675. He can type 675 words in 15 minutes. Okay? We'll finish 2 and 6, and then you get to practice on the bottom here. So, same thing, 23 miles per gallon. I'm going to take a second to set it up and write it out. Same right here that we were using up here in number 1. How much gas will he need to go 500 miles? Line up the labels. So 500 miles would go on top with miles. How many gallons would be what I'm looking for. Cross multiply. 500 equals 23x. Show this work on your paper, right? Solve to get x by itself, and I get 21.7 gallons. Or in number 6, still 45 words per minute. How long will it take him? So I'm looking for the time here. How long will it take him in minutes to type 3,000 words? Okay, cross multiply. 3,000 equals 45x. Show your work to solve it. And I get 66.6. Label. I was looking for minutes down here. So 66.6 minutes. Okay, so you've got kind of 2 more examples. If I have a biker going 12 miles an hour, there's 2 questions. And then the cost of cashews, $3.79 per pound, and 2 questions with those. So pause and try those, and then we'll come back and check. Okay, really make sure that you have it set up correctly, that every single number you wrote down has a label on it. And then I didn't show the work, but I was just cross multiplying each of these once the proportion is set up to find whatever number was missing. So check those answers, and then we'll go on to the back. Okay, this section at the top, number 9, I just wanted to point out that you have to be really careful when you have different units. So this example says Mr. Livingway eats 80 donuts every month. So I'm looking at donuts and months. So I know I can set that up. That's the ratio I know, 80 donuts in 1 month. But then each of these questions might ask me about a different unit of time. How many donuts will he consume in a year? Well, a year is 12 months. Line up the labels that you so that they all match. So 12 months would go here, and I'd be looking for the number of donuts there. Or still 80 donuts in 1 month. Now it says how many donuts does he consume each day? Well, there are 30 days in a month, we're going to say. So I can't use months and days at the same time. I have to change one of them. Well, it's probably easier if I change it into days, so I don't have to use some fraction of a month. So let's actually change this to in 30 days. 80 donuts in 30 days. How many donuts in each day? 1 day would look like that. Or how many donuts does he consume in a week? Well, so 4 weeks are in a month. So let's convert that. If I know he actually eats 80 donuts in a month, that's 4 weeks. How many donuts would that be in each week? 1 week. Would look like that. Or how many donuts in a decade? In 10 years. Well, then you could take your answer from here and set it up. So if you know how many he eats in 1 year, how many donuts would he eat in 10 years? So just pay attention to the units. Sometimes you have to kind of convert some things in your head before you can set up your proportion. So I just wanted to show you those examples. Okay, actually skip to the next page. So this is page 2. Find the question about 7th graders and 7th graders, how many girls and how many are boys. In this one, they're telling me 5/11ths of the students are girls in the 7th grade. And I know that there are 253 students in the 7th grade total. So this is a total number. How many girls are there? How many boys are there? Well, 5/11ths, so just under half are girls. Let's find out how many that is. Again, I can set up a proportion with what I know and just make sure I label everything. There are 5 girls out of 11 total students. So how many girls would that be out of the 253? So I could cross multiply that and get an answer for how many girls. I'll do that quick. So you can check my cross multiplication, but I solved for x and got 115 girls. So how many are boys? Well, there's 2 ways I could get this. I could say, okay, there were 253 total minus 115 that were girls, and I end up with 138. So there should be 138 boys, but let's just check with the proportion. If I know that 5 out of 11 were girls, then the other part must be boys. So if 5 out of 11 are girls, that must mean that the other 6 out of that 11 are boys. So I could set up the same proportion again, but with boys, and solve for how many boys. And when I cross multiply this, I do get the 138 boys. So just showing you that you can check it with the proportion again. So skip down to number 3, and I want you to try this one. Set that one up just like we did in number 1, and then come back and check it. So I know these don't round to pretty numbers, but that's what I got when I set it up and solved number 3. Okay, we're just going to do 2 more, number 4 and 5. This one says the ratio of dogs to cats at the local Humane Society is 8:18. So this is dogs, and that's cats. If there are 156 animals in total, just cats and dogs put together, how many are cats? How many are dogs? Well, there's a trick here. And this trick is if they give you a total number, kind of like we did on the front side, I'm going to need to know the total of these 2 parts when I add them together. So 8 and 18 make 26. So when I set it up, because this is asking me about a total number, I'm going to have to say 8 out of 26 animals. Oops, that's dogs. 8 out of 26 are dogs. How many is that out of the 156? And then 18 out of 26 are cats. How many is that out of the 156? We're almost out of time on this video. I want you to pause and finish 4 with the cross multiplication and then go and do 5 and then come back and check. Okay, check these and then that's it for the video. Thanks.